Don't forget to subscribe and ring that bell.
Why, hello. How you doing? Good to see you back. We are going to continue the practice 2012 AP Calculus AB exam that College Board put out over a decade ago. No calculator for this section. Boo. This is section 2, part B. All right, 4 problems, 3, 4, 5, and 6. We are going to do free response question number 3. You may have noticed that I have a new, I guess, profile pic for my YouTube channel. That is my dog. She is a Shiba Inu named Flora, and she is beautiful, so I figured why not use her with the glasses and the bow tie. Super cute. So, like, subscribe, ring the bell, leave some comments if you want to see something as far as what year of a test you might want to see me do, as I take requests, and let's get started. Okay. Graphs and charts and tables. Oh my, I love graphs. Number 3 says, let f be the continuous function defined on the interval from -4 to 3 inclusive, whose graph consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be the function given by g of x equals the integration from 1 to x of f of t dt. A asks us to find the values of g of 2 and g of -2. Okay, let's get started with this. Let's start, first of all, with g of 2. Boom. G of 2 means I'm going to put a 2 in for any x in my g function. Okay, there is one x, that is the upper bound. So I'm going to do an integration from 1 to 2 of f of t dt. No calculator. It doesn't matter because we do not have an equation to integrate. But remember, integration is really area under the curve, and this is going to be nice for us because we have 3 straight lines in a semicircle, so that will make life a lot easier to solve for areas because we're going to use the area formulas for basic shapes. So let's identify. We are going from 2 to 1. So 1 is right. Did I do that right? Yeah, 1 to 2 on the x-axis. Okay, why is that not? That seems weird, but I guess that's what we're doing. Such a small area. So I just want this area right here that I'm highlighting in blue. Oh, that's just when x is 1. It's when x is 2, all right? So the area of a triangle, okay, the area of my triangle is 1/2 base times height. So it's 1/2. My base, which we'll call the straight line here, is a distance of 1. And my height right here, all right, I don't have a y value here, okay? But we can figure out what the slope is, okay, and figure out how far down it goes for every one value of x, all right? Change in y over change in x. Let's do this. I go from 0 to -1, so I go down 1. I go down 1. And then for my x's, I go from 1 to 3. So I go to the right 2. Okay, -1, 2. That's my slope. For every one direction, one unit, I go this way on the x-axis, I go down 1/2. So this distance is -1/2. All right? Now, for that distance, for shapes, we never use negative, do we? We always say it's a +1/2. But that negative will come back in a moment, so let me explain. I suppose you can put -1/2 there, but I'd rather you get the concept of the area under the curve, okay? 1/2 times 1 is 1/2. 1/2 times a 1/2 is 1/4. But that's not the answer. It's negative 1/4. How come? Well, you could say, well, I should have made this negative. Yes, but, okay, anytime we do integration in area under the curve, anything below the x-axis is considered negative, and anything above is considered positive. So this area should be negative 1/2 because it's below the x-axis. And I think that's important to understand when it comes to integration. All right, so that's g of 2. I almost said g of t. That's g of 2, negative 1/4. Let's find g of negative 2. You know, I know it's only November 14th, but I am just in a Christmas mood already. And this green just makes it pop even more. So I'm going to integrate. Remember, my x was up here. So when I put negative 2 to 1 of f of t dt. Well, the first thing I'm going to recognize is that my bounds, my upper bound, negative 2, is actually smaller than my lower bound, which is 1. So I'm going to flip those. Okay, but whenever I flip my bounds, there is a rule. I need to negate my integral. Okay, so now that's equivalent. So we are still going to do area under the curve from 1 to negative 2, okay? Or from negative 2 to 1, I should say. All right, well, here's negative 1. Here's negative 2 right here. To 1, which is right here. So we want the area of this triangle, which should be positive because it's above the x-axis. Right. And we want the area of this semicircle, which should be negative because it's under the x-axis. We're going to combine them. And then, oh, let's not forget, whatever answer we get, we still need to make it negative. We need to negate it. Okay? So let's do some math, shall we, kids? I'm not in the mood for black. I mean, gray. Okay, gray. Let's first worry about the area of this triangle. Again, it is 1/2 base times height, which is 1/2. My base, this is a distance of 1. And the height is 3. All right, so 3 times 1/2, well, 3 times 1 is 3. And 3 times 1/2 is just 3/2. That's the area of my triangle. So I come down here, and I need to negate the area of my triangle plus the area of my circle. This is 3/2 plus the area of my purple. The area of the semicircle. Okay, first of all, the area of a circle is pi r squared, but it says we have a semicircle. So that's half of a circle, so I'm going to multiply it times 1/2. The radius is 1. So I have 1/2 pi times 1 squared. 1 squared is still 1. 1 times 1/2 is 1/2. And 1/2 times pi is just pi over 2. That's the area of my circle, pi over 2. So let's bring this down here. Now, we said it's pi over 2, but didn't we just say anything underneath the x-axis is negative? This should be a negative value. So when I come down here, and it's very tricky, okay, to keep track of all these negatives. What do you mean all these negatives? Because there's this, and there's this one outside. So let's clean everything up. I'm negating 3 minus pi over 2. Well, let's combine that. 3 minus pi over 2. But now I got to negate it, which means I'm just going to distribute this negative sign. Negative 3 plus pi over 2. That's the value of g of negative 2. That was, I mean, the algebra isn't difficult. It's being patient and taking your time and not making a mistake. okay? Because there's a lot going on. You're juggling a lot of tennis balls, so to speak. All right? 3A, done. 3B states, for each of G prime of negative 3 and G double prime of negative 3, find the value or state that it does not exist. All right, well, that's fine. First, negative 3 is negative 1, negative 2. Negative 3 is right here. It's at this point. Okay? Right there. Now, what was G? Let's state what G was. That was the integral from 1 to x of f of t dt. Okay? So let's establish first, before we plug in the negative 3's, let's figure out what our derivatives are. Meaning, let's find, okay, let's find g prime of x first, then we'll throw in the negative 3. All right, so if g of x is the integration from 1 to x of f of t dt, and I want the derivative of this side, that means I take the derivative of this side, I take the derivative of the right side. This gives me the derivative of g, and the beautiful part here is derivative and integration cancel. The dummy variable goes bye-bye, and this variable replaces this one. So really, the derivative of g is just f of x. That's cool. That's nice. So now I got g prime of negative 3, which means I just want to find f of negative 3. I mean, I don't know. Seems simple. Okay. 3 is 2. Right? Negative 3 is my x, my output, or y, is 2. Now, if you're going to say, well, that might be 1.97, whatever, you can do slope, change in y over change in x if you really want to. Meaning, my y's go from 3 to 1. So I go down 2. And my x's, no, let's not do the crayon, go from negative 2 to negative 4. Okay, which means that goes to the left 2, which means I get negative 2 over negative 2, which is a positive 1. Which means for every time I go this way 1, I go down 1. Okay, which means I go from 3 to 2. So there are ways to algebraically calculate that, but the answer is still 2. Okay? 2. G prime of 3 is 2. Now, if we know g prime of x is just f of x, okay, well, now I got to take the derivative of this to get g double prime of x. If I take the derivative of one side, I'm going to take the derivative of the other, and yes, that gives us f prime of x. So the second derivative of g is basically the first derivative of f. Okay, and now I want negative 3 in here for x. So derivative at negative 3, that's just saying the slope. Derivative is the same thing as slope at x equals negative 3. All right? We just calculated a slope because some of you guys weren't sure if this was really 2. You're like, this guy got to make sure that that's fine, whatever. Dag nabbit. The slope is 1. That's what we just did here. It's 1. The value of the second derivative of g at x value of 3 is 1. That one was nice and easy. All words, no numbers. It's freaking me out, man. C reads, find the x-coordinate of each point at which the graph of g has a horizontal tangent line. For each of these points, Determine whether G has a relative minimum, relative maximum, or neither a minimum nor a maximum at that point. Justify your answer, which just means, you know, your math work and reasoning. You're fine. There's no explain, so you don't got to write a paragraph or a statement. All right? All right, so let's break it down, DJ Lance, and we're going to use orange. It is November, and I said I was happy for Christmas coming. We haven't hit Thanksgiving yet. But you know what? I don't think 5 or 6 weeks is enough time to have a tree up. If I put it up after Thanksgiving, I basically have 4 weeks, maybe, till Christmas. Okay? And for all that effort to put up the lights and the tree, it's like, I want to see it a little bit more. And of course, you know, it's going to go through New Year's too. So I'll take a good solid 7 weeks if I can. But I appreciate turkey and mashed potatoes and gravy and stuffing and all that good stuff too. So let's go with orange. Find the x-coordinate of each point, which the graph of G is a horizontal tangent line. That means the slope, which is the same thing as the derivative, is 0. Okay? Horizontal tangent line. All right, so the derivative of G, which we just did last problem, let me remind you right here, the derivative of G is just f of x, okay? Where is that equal to 0? What values of x make that equal to 0? Oh boy, we are going to need a copy of the graph. That would really help us here. Presto changeo, we have a graph. I'm not a magician or a god, but I just paused it. I did the snipping tool. Anyways, so here we go. If the first derivative of G is f of x, okay, and if the first derivative of G is f of x, and we want to find out where the first derivative of G is 0, that means you want to find out where f of x is 0. All right, well, let's look at the zeros on the graph of f. And it happens at 2 points, here and here, okay? And that's where, let's go, we said we were going to use orange, so let's not deviate from that. When x is -1 and x is +1. Okay, so this happens at an x value of -1 and 1, all right? So now what we need to do, okay, is say, well, is there a relative minimum, a relative maximum, or neither? Okay, well, let's recall that the f is the same thing as the derivative of G, right? In order to have a maximum, I want to have a positive slope or a positive derivative, or in this case, a positive value of f, and then a negative. Okay, that's how we get a max. To get a minimum, we want a negative derivative to a positive derivative, keeping in mind that the derivative is the same thing as the value of f, which is just my y value. So let's take a look at -1 right here. As I go left to right, these are positive y values, which means a positive value of f, which means it's a positive derivative of G because the derivative of G is f. Okay? It's still positive. These are positive y values, positive, positive, positive. It hits our 0, and then it goes negative, negative, negative. Okay, so we went positive to negative here. Positive, hit our 0 to negative. That means I went positive to negative. I need to have a max. Okay, there's a max at x equals -1. Okay? And what are we going to say? I mean, I know our math works good, but we don't have any calculations, so we'll write a quick little statement. Okay, since, okay, I can say f of x, or I can say g prime of x, because they're the same thing. I'll say f of x, because that's what the graph we have is. Since f of x is greater than 0 when x is less than -1, and changes f of x is less than 0 when x is greater than negative 1. Okay, so it changes right at negative 1. All right. I mean, I suppose I could say until I hit. No. I'm going to leave it like that. I'm going to leave it just like that. It's good. It's good. So we have a max, a relative max. Let's throw that there. Relative max. I don't know if it's the absolute max, but it's definitely at least one of the maxes. All right. So, but we just checked negative 1. Done. Good. Let's check positive 1. Okay. So as I go from left to right, I'm going to continue. This is still negative. It hits 0, but guess what? Then it stays negative. It does not change this way, and it does not change this way. So there is no min or max at an x value of 1. But we need to state that. There is neither a relative max or relative min at x equals 1. And again, these words can be written one of a million different ways. Since f of x stays negative before and after x equals 1. Okay, so the sign doesn't change. You could have said that as well. There are one of a million different ways. I had an Algebra 2 test that I put up, and I made an explanation like that, and then someone's like, well, how about this explanation? And it was a comment they left, and it was this highly detailed paragraph that an English teacher would have been proud of. And I could have been like, overkill, but I didn't. I was like, that is very detailed. That is very precise. I like it. And I mentioned again, it is one of yet a multitude of ways you can do it. So, but I wanted to I wanted to give them positive feedback on that. You like to boost people up, especially with math, because I know how people just have such a fear or hatred of math. It's crazy. All right, so that's 3C. We have one more problem, or one more part of 3. Let's do it. This time I brought the graph first, and I pasted it right there. Anyways, D says, for an interval of x from negative 4 to 3, find all values of x for which the graph of G has a point of inflection. Explain your reasoning. This time we absolutely have to use words, all right, which is, that's cool. That's cool. So let's just do this and get done with this whole filthy poop. All right, let's go here. Let's go this bright green. I like the mint green, but I'm not sure if it pops too much. It might be harder to see for some. So in order to have an inflection point, that means the second derivative of G has to be either 0 or undefined. And then at that point, it's going to change signs, right? It's just like slope, but it's concavity. All right, it has a change slope or concavity, which it happens to do at these 3 points, but we'll get there. And I say 3 points. How come? Because for B, remember the second derivative, I should write it down here. The second derivative was the derivative of f. So let's go back here and make a little note that the second derivative is equal to the first derivative of our graph here. And that's the same thing as the slope of our graph. And I want to see whether either 0 or undefined. Slope. Well, I see 3 points right away. The crayon, that crazy, crazy crayon. All right. Anyways, that is a corner. It is undefined. That is a corner or cusp, undefined. And right here, there is a horizontal tangent line, which means it has a slope of 0. So I'm going to make a little note here. At x equals, okay, this is an x value of 0 right here. X equals 0, f prime of x is 0. And at x equals -2 and 1, at -2 and 1, the derivative of f of x is undefined. So those are our 3 points. All right, those are our 3 points. And what I'm going to say is as follows. Now, instead of thinking about the value of f, remember, at this graph right here, we were talking about the value of f. All right, let me go back to that nice green. We're talking about the value of f. The y value, it went from positive to negative, okay, and so forth. This time we're talking about the slope of f changing. We're talking about the slope of f. Okay, here's the first one. Positive, 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 positive slope. Okay, undefined slope. Negative, 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 negative. So it does change there. Okay, it does change. It changes signs right there. Okay, it continues negative, 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 negative. Okay, ooh, and there's one thing I see, but I'll point that out in a moment. Then it goes from a 0 slope, and then it goes positive, positive, it's increasing. 0 slope again, then goes back to decreasing, 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 decreasing. Now, notice as I go from left to right, oh, I should do this with a nice highlighter. A nice orange highlighter. Let's do this. The orange highlighter, boom. Positive slope to negative slope. So it does change signs here. Negative slope to positive slope. So it does change signs here. Positive slope to negative slope. So it changes signs at all 3. And you might say to yourself, well, Visca, this kind of looks like a corner as well right here. It should be, the slope should be undefined. So should that be one of the values here? It should be. But for our answer, notice it doesn't change slope. It stays negative. This is not, it does not qualify as a point of inflection because it does not change signs. The slope goes from negative, has that little corner, and then it continues with a negative slope. All right? So let's just write something brief, okay? The second derivative of g equals the first derivative of f. Okay, I'm just going to make that statement. And that changes signs, okay, at x equals -2, 0, and 1. I like putting these 3 dots for therefore, but I'll write. Therefore, sounds official. There are points of inflections there. When I say there, I'm referring to these. And again, some of you might come up with a better way to write that. Some of y'all might, I don't know. Let me drink some coffee here, kids. Some of you might come up with better ways, and some of y'all are going to half-ass it and write a terrible explanation. Don't do that. Be specific, even if you're being brief in your explanation. Okay? Make sure you don't lose the points because you obviously know what you're doing. We are done. Follow me, like the video, you know, ring that bell, and, you know, my dog, Flora. She's pretty damn cute. I will see you guys for the next video. Free response question 4 coming up very, very soon.